All right, so here's a video for the review for Unit 12 test that we're going to be taking. So first question says determine if it's a tangent. So the question isn't, find this. A lot of times when we did these problems, students were like using Pythagorean theorem. So like, hey, this is 6. I'm like, that's not the point. The point is to determine and prove that this line AB is a tangent line. So all you got to do that is use the Pythagorean theorem with 8 and 6 as the legs. And then you have to add these two. And again, this 6 wasn't there to begin with. You know it's a radius, and all radii are the same. So that's why that's 6. So you 6 squared plus 8 squared equal 10 squared. That's a question. You answer that question, and the answer to the question is yes. So therefore, AB is tangent. So number 2, it says AB and AC are tangents. So now you use the property in reverse, and that proves that these are right angles. So now if those are right angles, now I have a quadrilateral. So there's a couple ways you could do this. You could see a kite if you want to call this a kite. It's up to you. But as a quadrilateral, all angles in a quadrilateral make 360. So then I got a 90, a 125, and a 90. And I got an unknown angle, so I subtract the 3 I know from 360 to find my unknown angle, 55. Number 3, trying to find, again, two tangents from the same outside point are equal. This one's pretty straightforward. You just set these two numbers equal to each other. Simple equation setup. X is 14. And now you want to find JK, you just plug it in. Number 4, find missing measures. So let's zoom in a little bit on this one so I can show you what I did here. So because the angles and the arcs, central angle is equal to the arc, I put this 2x plus 18 in here, right? So the other thing I know is that I just tried to find all the angles I know. I know these are vertical, right? I know that these two angles make 180, so 40 and 140 need to make 180. So the first thing I had to do was I had to find x, right? So I couldn't really find the other angles until I found x. So in doing that, I took 42. So I took this straight line here. So 42 plus 2x plus 18 plus x, and that makes a straight line, makes a 180-degree angle. So I'm going to add those three equal to 180. I end up with 3x equals 120. X end up equaling 40. So then, once I figured that out, I plugged it in, and that was the trick to the whole problem, right? So once you found x, you have to plug it in. So 2x plus 18 is 2 times 40 plus 18 gives me 98. So I'll write that in here so you can see that. So this angle and arc are 98. X is 40, so that angle here, that is x, is 40, and that vertical angle is 40. Since these two make 180, these are supplementary. You take 180 minus 40. So now I got all the angles and all the arcs, and I could just figure out which ones they're looking for. So NP, that's 140 because I found it already. And then NQL, so let's highlight that. So NQL, if I could look at that, I start at N, and I got to end at L, and I got to go through Q, right? So it's got to start at N, go through Q, and end at L. So there's NQL. So a couple ways you could have done this. I chose to take 360, the full circle, minus the two angles inside, that I don't need. So I took 360 minus 82. You could have just as easily gone 140 plus 98. Either way, you should get 278 degrees. So a lot of stuff going on in this question, but it's just, the whole circle makes 360, straight lines make 180. A lot of this stuff we've been talking about, so hopefully it's not too bad. Number 5 is a little easier. You just set these two equal. Again, two arcs. Since these chords are equal, the arcs are equal. You solve, you set them equal. HE, you plug in. GF, you plug in. Not too hard. Number 6. Number 6 is a good one. We practice this. But so looking at it again, since this is 2 and this is 1. Since this is 2 and this is 3, I know this is 1. It didn't really ask me for that, but I know that full radii, GH and HF, are both 3. So in order for that to happen, that's what you get. So they gave me the things I need. So I'm going to take 2 squared plus DF squared equals 3 squared, right? So you find DF. DF squared is 5. DF is root 5. So then DF is root 5. EF, since DF is root 5. So this is root 5 and root 5. So you just say what's root 5 plus root 5? That's 2 root 5. So that's why the answer to that one is 2 root 5. All right, next page, you got a couple formulas here. So you want to find the area of the sector. I didn't write it on the line, but it's right there. So the area of the sector ended up being 675 pi over 4. You use the formula for the area of a sector, which is the measure of the arc over 360 times the area of the circle. So area of the circle we found here is 225 pi. If you're not sure why that is, let's talk about it. The area of a circle is pi r squared, or if I say r squared times pi, so the radius is 15. So 15 squared is 225. So I got 225 pi. That's it. So that's how I found the area. And now you take the measure, which in this case, since the shaded area is the majority of the circle, then I take the measure of the arc is 270, right? So I know that that's 90. So I take 360 minus 90, give me 270, and that's how I figure this out. Use your calculator to do the rest. Number 8 is a tricky one. So this one asks me for a few things. And looking at this problem, we'll practice this in class probably. So I'm going to look at this triangle, this sector. So to find the area of the segment, which is this part here. Again, it's like, what is the area of the segment? We didn't talk about that. You're like, what does that mean? So this would be that part there. So if I could find the area of that, I'm going to need to take the area of the sector and then subtract the triangle, and then I get what's left. So we did this in class with a different kind of segment, but this is how you do it. So you take the area of the sector, which is 120 over 360, times the area of the circle, which is 16 pi, because radius 4. And the area of the triangle, now this is the tricky part. So this is a triangle with a 120-degree angle. If you drop this altitude, that creates a right angle. And when you do that, you create a 30, 60, 90 triangle with a hypotenuse 4. So now hypotenuse 4, short leg 2, long leg 2 root 3. So then the whole base is 4 root 3. The height is 2, so the area ends up being 1/2 4 root 3 times 2. 1/2 of 4 root 3 times 2 is 1/2 of 4 is 2. 2 times 2 is 4, so you end up with just 4 root 3. So 4 root 3 is the area of the triangle. 16 pi over 3 is the area of the sector area. So the area of the segment, this part, again, this little french fry looking thing, the area of that is just going to be the subtraction of the 2. Number 9, talk about arc measure and arc length. So it says the measure of MN. So it's the measure of arc MN, so you can find the arc length here. So it should have said length of arc MN, but anyway. So I'm going to take measure over 360 equals times the circumference. Now the circumference is diameter pi, so the diameter is 24. Diameter pi is 24 pi. So you plug it in your calculator, you basically get 1/8 of 24, which is just 3 pi. This one's a backwards problem. We practice the central angle of a sector is 72. The sector is area 20 pi, so you find the formula. 20 pi is S, 72 is M. Solve for A. Now you're going to take this. You're going to multiply by the reciprocal. So there's a lot of ways to solve this, but essentially you're going to end up with 100 pi as the area. If the area is 100 pi, we know area equals the radius squared pi. So if the radius squared is 100, then the radius has got to be 10. All right, last two on this page. So this one's pretty straightforward. If the angle x here is 114, then the rest of the circle is 360 minus 114, it's just 246. Number 12, another practice with the same kind of thing where I'm taking, I got straight angles, straight lines make 180, vertical angles are congruent, so there's a lot of stuff going on. So y has got to be vertical to 34, so that's why y is 34, right? These straight lines make 180 degrees, so I could find z by taking 54 and 34 from 180, so I could do 180 minus 54 minus 34 to find z. All right, x, well now I know y is 34, you know, and I could use this one too. This is straight line, so 34 subtracted from 180 would get me x. So a lot of stuff going on with that problem, hopefully not too bad. All right, last page. And looking at number 13, you got this triangle. So this is a little bit of a different one because the numbers aren't quite as pretty. So what I chose to do, looking at the problem, was I chose to take 8 squared plus 17 squared. So the question is, point A is tangent. So I know that makes this a right angle. And the question is how to find x, right? So I'm trying to find this part essentially makes from here to here, right? So what is the length of that? So I know this is 8. But again, I'm looking at the whole thing as x plus 8. So I'm just going to call the whole thing BP. So my formula, I'm going to take 8 squared plus 17 squared, Pythagorean theorem, leg squared plus leg squared, equals hypotenuse squared. So I'm not worried about all this x plus 8, all that stuff. I'm just going to call it BP squared. So when I do that, I could find that whole side, right? So what I determined when I did that is that this whole side is 18.8. Okay? So I know I'm writing this really far away, but that's how long BP is. So if I know that BP is 18.8, and I know that the radius is 8, it's really simply just 18.8 minus 8, right? So that the length of x would be 10.8. It's a little bit of a tricky one, but looking at it, if you just find that side and then subtract 8, it's really not too bad. Number 14 is a system, the two equations you should get, because it tells you, read the problem, it says that the two radii they give us are 3x plus 2y and 9x minus y, and the radius is 7. So if the radius is 7, I got 3x plus 2y equals 7, 9x minus y equals 7. So to find x or y, I can multiply the whole bottom equation by 2, right? 3x plus 2y equals 7 doesn't change. This becomes 18 minus 2y plus or equals 14, and you add straight down. That cancels these. 3x plus 18 is 21. 7 plus 14 is 21. X is 1. So that's all I had to find was x. So you had to find y. You could plug it in to find y. It shouldn't be too hard to do, but you would plug it into either one. Y is going to be a decimal, but you just find x in that case. Now 15 and 16 are good questions. If the circle says if the circumference is 12 pi, right? We know that circumference is diameter pi, right? So what I know, if it's 12 pi, diameter is 12. So if the diameter is 12, the radius is 6. If the radius is 6, then the area is 6 squared pi, right? So we've said this a few times already, but area is radius squared pi. So that's how you do that one. 16, find the circumference of a circle whose area is 49 pi. So now I'm looking, okay, area is 49 pi. We know area is radius squared pi, so radius squared is 49, radius is 7. We know circumference is diameter pi. If the radius is 7, the diameter is 14, so the circumference is 14 pi. Again, this takes a little bit of practice, but it's really not anything too crazy here. Last problem. It says identify the picture and identify the following terms. So we got to know what these terms are. You could look at this, pause it if you need to. I mean, I could talk about it, but essentially a radius goes from center to edge. Diameter goes all the way across the circle through the center. A secant is a line. So the difference between secant and chord is key, right? So they're the same letters, but a secant has a line above it, a chord is a segment. So the chord is segment LM, the secant is line LM. Segment, chord, secant, line, right? Then a tangent just grazes the circle, touches it at one point, and that's basically all the terms.